Hi, this is Mr. Mac, and I promised I would make a video on the chain rule. So let's see what we can do here. First of all, the chain rule says that if you have a composition of functions, in other words, if you want to take the derivative with respect to x of f of g of x, then what you're going to get is f prime of g of x times g prime of x. Now, maybe a little bit later we can talk about why this makes some sense. But to start off with, let's go ahead and take a look at a proof of this, and then maybe a few examples. Now, this is what we want to prove, and what I'm going to do is I'm going to use the alternate form of the definition of the derivative. In other words, I'm going to say that f prime of x is equal to the limit as x approaches a of f of x minus f of a over x minus a. And this is the alternate form of the definition of the derivative. Now, to prove this then, we would say that the derivative with respect to x of f of g of x is equal to the limit as x approaches a of f of g of x minus f of g of a over x minus a. Now, a couple of statements here. Both f and g need to be continuous functions here, because if they're not continuous, if they're not differentiable, in other words, if they don't have smooth curves, then you've got strange things going and there won't be a limit. But so we imagine here that we've got smooth, continuous curves. If that's the case, then as x approaches a, f of x will approach f of a. So what I'm going to do then is I'm going to rewrite this, and I'm going to say the derivative with respect to x of f of g of x is equal to the limit as x approaches a of f of g of x minus f of g of a over x minus a. And then I'm going to multiply that by 1. Now, the 1 is going to be g of x minus g of a over g of x minus g of a. Once again, why did I do that? Because it works. All right. Now, that means that this is equal to the limit as x approaches a of f of g of x minus f of g of a over g of x minus g of a times g of x minus g of a over x minus a. Remember, when you're multiplying, multiplication is commutative. When you multiply fractions, you multiply the numerators together, and then you multiply the denominators together. So by commutativity and definition of multiplication of fractions, I can exchange the denominator g of x minus g of a with x minus a. But now, as x approaches, let me just make a little arrow here so we can point. Now, as x approaches a, we know that g of x approaches g of a, so the limit as x approaches a of f of g of x minus f of g of a over g of x minus g of a is f prime of g of x. And we're multiplying that by, now the limit as x approaches a of g of x minus g of a over x minus a is g prime of x. And we have the proof that we were looking for. Now what does this mean? Well, f of g of x is the composition of functions. In other words, we have some input that we put into g, but then the output of g becomes the input of f. And so if we want to know how fast f of g of x is changing at some instantaneous point, then it's the rate at which f is changing at that point times the rate at which the input function is also changing. Now let's take a look at a few examples of the chain rule. For example, if we want to take the derivative with respect to x, let's do something like 2x squared plus 4 cubed. See, the derivative with respect to x then, by the chain rule, notice that the outside function is the cubing function and the inside function is 2x squared plus 4. So we would get 3, that's this 3 right here, times 2x squared plus 4 to the 3 minus 2, 3 minus 1, which is 2, times then, by the chain rule, the derivative of the inside function, which would be 4x. I'm tempted here to do a little bit of algebra. Let's go ahead and do a little bit of algebra. What we get here is 3, oh, well, actually, excuse me. Let's just multiply the 3 and the 4x together. That gives us 12x. And then 2x squared plus 4 becomes 4x to the 4th plus 2 times 2 times 4 is 16x squared plus 4 squared, which is 16. And then if we multiply all of that by 12x, we get 48x to the 5th plus 12 times 16. What would that be? 196 minus 4. I think 192 x cubed plus 192x. Now, let's take a look if we do this one in a slightly different fashion. See now, 2x squared plus 4 cubed is going to be is equal to 2x squared cubed plus 3 times 2x squared squared times 4 plus 3 times 2x squared to the 1 times 4 squared plus 4 cubed. Let's see what we get there. This becomes 8x to the 6th plus, this is 4x to the 4th times 4 is 16 times 3 is 48 x to the 4th plus 2x squared times 3 is 6x squared. 6x squared times 16 is, I think, 96x squared plus 64. Now, if we were to take the derivative with respect to x of this, 8x to the 6th plus 48x to the 4th plus 96x squared plus 64. we would get 8 times 6 is 48 x to the 5th. 48 times 4 is 160, 192 x cubed, and 96 times 2 is 192 x, and the derivative of 64 would be 0. Now let's look back. I don't really remember exactly what it was. Oh, look at that. 48x to the 5th plus 192x cubed plus 192x. As the Spaniards would say, lo igual. Now the chain rule needs to be followed through. It turns out that, let's just do this. If you want to take the derivative with respect to x of f of g of h of x, let's see, 1, 2, 3, 1, 2, 3, yeah, okay. You have to follow this through. You get f prime of g of h of x times the derivative of g of h of x, which is g prime of h of x, times the derivative of h of x, which is times h prime of x. And this chain can keep on going if you have more inside and outside functions. I think I'm going to let you just kind of, well, maybe one more example. Let's do something like this. Let's take the derivative with respect to x of e raised to the sine of x squared. Okay, now, first of all, you kind of have to classify in your minds what is the outside function, what is the inside function. The basic outside function is e to a power. And then what we have is inside here, we're taking the sine of something. And then what we have inside here is a function that is x squared. So the outside function is e to a power, and then inside that is the sine of something, and the something is actually x squared. So what we would do in taking the chain rule is the derivative of e to a power is e to the power. So we get e to the sine of x squared times the derivative of the sine of something by the chain rule. Now the derivative of the sine of something is the cosine of that something. And then we multiply that by the derivative of the something, which is 2x. So we would probably clean some things up here. We'd probably say that this was equal to 2x e to the sine squared of sine of x squared times cosine of x squared. I don't know what order it needs to be in, but basically there's applying the chain rule twice. You may even see it done 3 or 4 or 5 times, although after a while it gets a bit tedious. Okay, so there's the chain rule. I think I covered the things that I wanted to cover in this short video. I don't know how short it is, but there we go. So I'm going to sign off now with, and we're done.